Canvas. Okay, so it's recording now. And so what I'm going to do is I'm going to get out of here. And I have an actual printout of that help sheet. Okay, so as we said, quadratic functions have this generalized form, and where these a, b, and c are real numbers. And the graph of a quadratic function is a parabola. So it'll either open up or it'll open down. They can be fat or skinny. Okay. And then if we have paired data and we look at our scatter plot, we can usually see whether or not there's going to be a relation there that correlates to a quadratic. And here's some examples. So, and on these particular ones, they've gone ahead, they've looked at them, they've eyeballed them, said, yes, it's a quadratic relation, and they've had their calculator work out what the equation of that quadratic function would be, and so they showed it in the same graph. Okay. But here, this is just the scatter plot alone, and you should be able to eyeball that and say, yeah, I'm seeing a parabolic shape there, so that should be a quadratic regression. Same here. Here's one that opens down. But we want to make sure we understand you don't always get the complete hump, as it were. You can have this situation where these dots are coalescing around a part of a quadratic function that doesn't show you the entire hump, like what's being done in these two. Okay. And this is where we have to be careful, because sometimes if I were to take out that solid curve and you're just looking at that scatter plot, sometimes a student can mistake that for linear regression. Okay. But, and in the departmental assignment, they will not tell you whether or not it's linear, quadratic, or exponential. You'll have to judge for yourself. Okay. All right, so here's an example. And again, this is in your Canvas, so you don't have to madly write these down. The table shows the population of a city every 10 years after 1970. So they've already built in, instead of giving the actual years, so instead of putting down 1970, they're going to have your X values represent the number of years after 1970. So we can see that this city had a population of 489,000 in the year 1970. This city had a population of 801,000 in the year 1980. Okay, and the year here is 1990, which is 20 years after our time started in 1970. Okay, so look at the scatter plot and decide what type of regression equation will model the data. Okay, and so I have a couple of instructions there, but like I said, in this video, I'll go through this step by step. Okay. All right, so, and then we have a question. And in web work, you don't have questions on the quadratic, the cubic, or the exponential, because I couldn't find any exercises that did. You will on the departmental homework. So first thing we're going to have to do, well, I want to go here to y equals, and if I have anything in here, old data, I just need to clear it. Okay. Then I'm going to press stat, and if I just click enter on the editor, you can see I've got old data in my lists. You cannot write over lists unless they have exactly the same number of entries in them, and these don't. So I'm going to clear out list 1 and list 2. I always try and put things in list 1 and list 2 because that's a default command for many things, and I just feel better doing it that way. So I'm going to press stat. I'm going to scroll down to clear list, and I'm going to tell it I want to clear out list 1 and 2. So second key and the 1 key, then the comma key, which is right above the 7, and the second key and the 2 key, and then press enter. And it's telling me that's done, so I'm going to press the stat key, and then I'm going to press enter. And you can see here my 2 lists are cleared out. It's in list 2, so I'm going to scroll over to list 1, and I'm going to put my X values in there. Oops. Okay, so 10, 20, 30, 40. Then I'm going to scroll over here and put my Y values in. Okay, and I'm just going to double check those. Okay, that's looking good. So I'm going to press the stat key. No, I'm not going to press the stat key. I want to look at the scatter plot first. So I'm going to press the second button and the Y equals button. Then I'm going to press enter. And I want the plots on, so I'm going to press enter there. This is the default for a scatter plot, so it's already highlighted. And the default for your X list is list 1, which is why I put it in there. And the default for your Y list is list 2. And you can have the marks either as these open circle or as these crosses. I think yesterday I was using crosses, so I might use an open circle. I don't have to list anything in there because that's all default. And now I'm going to press the zoom key and the 9 key, and I will see what the scatter plot looks like. Okay. So we got to make sure we see this one right here. So it's right on that Y axis because the X coordinate is 0. So you don't want to, and you'll always have a place, a beginning, when you have a 0 value in there, so don't miss it, okay? Because it's really important to see. If you miss that one, you might think, oh, that's linear, and just with the data that we've got, we might be tempted to say it's linear, but what I'm actually seeing is a little bit of a curve there. Okay, so I'm thinking I'm getting this kind of situation. So I'm going to try quadratic regression. Now, the question here would be, well, what if I'm doing the departmental homework assignment and I wrongly classify this as linear instead of quadratic? Well, there'll be a point taken off for that. But if everything you do after that, so you get the correct linear regression equation, you answer the specific question correctly using your linear regression equation, if everything after that's right, you'll be given credit for it. Okay, so it's not going to be a domino effect where if you make a mistake like this at the beginning, then everything after that is wrong. Okay, but this, they want you to look at that and say that it does look like a quadratic. Okay, so that's what we're going to use. We're going to use quadratic regression. So now I'm going to press the stat key. I'm going to scroll over to calc and I'm going to find quadratic regression, and we should be able to see it. We'll scroll down here to number 5 and I'm going to press enter, and I need to tell it use list 1 for the X values and list 2 for the Y values, although list 1 and list 2 are default. So I'm going to second 1 comma second 2. Okay, now if I just pressed enter, I will get the same thing because I put my X values in list 1 and my Y values in list 2, which is the default. So let me just show you. I could have just pressed enter because I set it up to where my X values were in list 1 and my Y values in list 2, and that is the default. Okay, and I'm getting the same thing. Okay, all right, which is what I'm showing here. Now, you guys don't have tests where you, oh, and this R squared, I teach a statistics class, so I need that to show, and you have to go through some special commands in the catalog, internal catalog, to make it show. You do not need it to show for the Math 140 course. This is all that we need. Okay. Now, there have been instances when students took a test where they had to write in the regression formula. You're not going to be able to do this in an online test, but the instructions would say, because there'd be an answer sheet, and the instructions would say, what is your regression formula? And I would have a student copy this verbatim and just turn it in written like that. And that's not correct. We want the formula. And so this is telling me. And also, instead of y, remember y equals f of x if your function is called f. Here, my y values are population values, and so it makes sense to call this function, this population function, p of x. So that's what I'm going to do. And it's a quadratic, and so I'll go ahead and write the general form in. But now I'm not going to go on the next line and write a equals that and copy that verbatim. I need to put these numbers in to this formula. And we always take to 4 significant figures, which in most cases is 4 decimal places. So if I'm going to do this, my value for a is going to cut off there, and then that's going to bump that 2 up to a 3. And b, that 7 is going to bump that up to 6. And then plus c, and c is a big number there. Okay, that's my regression equation. And so that's shown there on the help sheet. Okay. Now, in web work, unfortunately, that's all they ask you for. And for the life of me, I don't know why they don't have any questions where they make you use this formula. So the question here, what was the predicted population for the year 2020? Well, if I go to this formula and I put in 2020 for x, then that's not correct, because these are my x values. And so I have to convert 2020 into an x value. And the x values are the number of years after 1970. So if I take 2020 and I subtract 1970 from it, that's where I get the 50. So the year 2020 corresponds to x being equal to 50 years after 1970. So the predicted population for 2020 is, you're going to have to take this regression formula, and the variable in here needs to be a 50. Okay. So everywhere there's an x, you put in a 50. And then you get this number. Okay, we got to be very careful here. It is wrong to say that the population for 2020 was predicted to be, and if I round that, okay, that's not a correct answer, because if we go back to our chart, we have the population, but in parentheses, it's in thousands. So I need to take this number and multiply it by 1,000, and then take that number to the nearest decimal place. So the population predicted, so for 2020, was predicted to be 4,177,437. Okay. Sometimes they'll ask you, what was it predicted to be to the nearest million? Well, to the nearest million, that would be 4 million. But if they don't tell you to round like that, just take it to the nearest integer. Okay. Now, another thing on the departmental homework, you must put your conclusion as a full sentence. So if the question is, what was the predicted population for 2020? And you write this down and then put a box around it, there's going to be points deducted for that. So we have to be clear here. You've got to give your answer as a full sentence. The population predicted for the year 2020 is, and then that number. Okay. That's what the department is looking for. So this is not following the instructions, and this is real not following the instructions. What is it? We got to see, department is looking for, the population predicted for the year 2020 is that. Okay, that's what we're looking for. Okay. All right, so that takes you through that example. And again, the web work is woefully inadequate to prepare you for the departmental assignment. I'm going to get that posted next week. There's 2 assignments. There's one on rational functions, and there's one on regression. Okay. All right, so we're going through quadratic, cubic, and exponential regression. Okay. Let's have a look at our web work. Okay. Let me go up here. All right, let's have a look at, all right, so we had linear, we had looking at the vertex. Okay, so here we have a population problem, and it says use quadratic regression. All right, so we have P of X. They supply you with the P of X, and you are to type in the entire equation. Okay. And then they don't ask you any follow-up questions. Just understand there will be follow-up questions on the test and on your homework, on the departmental homework. Got to be really careful with this one. The graph of such an equation is called a cubic. So they're telling you to use cubic regression. Here, you got to be really careful because they do want you to put, so find the multiple regression equation. Just means find the regression equation for the cubic that best fits the given data. And so they give you this function that they call y hat sometimes in statistics. Be very careful how they're asking you to put your coefficients in. Okay, they are wanting you to start with the constant and then the coefficient for x, and then the coefficient for x squared, and then the coefficient for x cubed. Be extremely careful there because in your calculator it gives them in descending order. So it starts with the coefficient for x cubed, then x squared, then x, and then that. So we're going to look at one like that. All right, so let me get back to this one. All right, so what are the shape of cubics? And so cubic polynomials have degree 3. Okay, so that's the general form that we put them in. And generally they have some kind of a kink there. Now you can see here that we've actually got 2 well-defined humps there. Here that it's more flattened, and the end behavior depends on, if that leading term is positive or negative. So a positive number times x to an odd power means we're going to have end behavior down up, so it's going to be this. And a negative number times x to an odd power is going to be end behavior up down. So we have something like that. Okay. And so these things can be quite flattened. Or they can be bendy like that. So again, the problem is if your data, when you look at the scatter plot, and you only see that part of the data, you can be forgiven for thinking that that looks like a quadratic correlation there. So hopefully, with the cubic examples that you're being given, you're going to have enough to see that you're actually having this type of relationship. So this one would be very obvious. Something like that can be quite tricky, especially if you don't have the entire graph. So let's look really carefully. This one is pretty obvious that you're going to have a cubic correlation there. This one, you got to be really careful, because if we, ignore this part and we're just looking at that, so you won't have the curve in there, we could very well understand why this might be confused for a quadratic. But what's happening there is it's kind of having a kick down. It's kind of doing a little fishtail type thing there. So let's have a look at this example. So we have the year given in this table. So this table's horizontal. So my list one values, or my X values, would be in the first row. And then associated with the year, paired with each year, is the number of AIDS cases reported. So this is paired data. And we do have the instructions here that they want you to rewrite that list and let t equals 0 for the year 1998. Okay, and so my function is going to be the number of AIDS cases. So I'm going to write my function with respect to capital A. So when they have this information here, they want you to rewrite your first list. Okay, so if it's in a column, you'll rewrite it, your first column. If it's in rows, you rewrite the first row. So we're not going to be doing years, we're going to be doing t. And 0 is equal to the year 1998. Well, the year 1999 is 1 year after 1998. And 2000 is 2 years after 1998. 3 years after 1998, 4, and then 5. So this is what we need to put in my list 1. And then my list 2, I'm going to have the actual values for the number of AIDS cases. So let's do that. So I'm going to go to y equals, and I'm going to clear out any, oh, okay, I don't need to clear out any old data. Well, that was the last thing I wanted to do on this one. Let's just check it before I clear everything out. Let's put this in here, 1.2093 x squared plus 12.9986x plus 504.2571. Then if I press zoom 9, you should be able to see how that quadratic fitted that data. And it is easy to see the quadratic if we understand that there is a point right there. Okay, if we didn't see that point, we might be, oh, it looks like linear. But with this point here, it kind of confirms it. Okay, so that was, I meant to do that for the last one, forgot to do it. Okay, so we're going to go to y equals, I'm going to clear that out. Okay. We're going to go to stat, press the stat button, and I have to clear out my old list 1 and list 2. So I have to tell it second, 1, and then the comma, which is above the 7 key, second and 2. Okay, then I'm going to press stat and enter, and you can see I have my 2 lists cleared. I'm going to scroll over to list 1. I'm going to put in my t values like we were told to do. And then I'm going to come over here and put in these number of AIDS cases in for my list 2. I have to be extremely careful on this one. Okay, now I need to double check Okay. Now, I would like to see the scatter plot for this data. So I'm going to press the second key and the y equals key. And I'm just going to come here to the first one. And I want the plot on, so I'm going to press enter. Now, everything else is default. The default highlighted is scatter plot, and the default for your X list, in this case, it's T list, but it will always appear as X on your calculator. So is list 1, and your Y list is list 2. So all I have to do is make sure the plots are turned on, and then I'm going to press zoom and the 9 button. Okay, now we should, and again, understand that there's a point right there, and it might be hard to see because it's right on the y-axis. And so I have a picture here, and so we should be able to tell with this, you know, we've got some kind of a situation like that, and that's going to represent a cubic. Okay. So from that, we should be able to eyeball it and say, yeah, that's going to be a cubic. So we need to use cubic regression with this. So I'm going to press the Stat button, and I'm going to scroll over to Calc, and then right down here, we're going to go to cubic regression. Now, again, the default is list 1 and list 2 for your values, which is what I put in there. So I don't even have to tell it list 1 and list 2. I can just press enter. This is an older model. But if you're required to tell it what your lists are, well, second 1, comma, second 2. But I didn't actually need to do that. Okay, so you can see how it automatically gives the cubic regression formula with the highest powers of X coming first. So you got to be really careful when you go to the WebWorks and you answer this question when you're filling in these blanks. So that's where your A is going to go. That's where your B is going to go, your C and your D for that particular one. So just be careful, be mindful about that. And always take your regression equations too for significant figures, which in this case, it looks like it's going to be 4 decimal places. And this R squared, you do not need to worry about that in this course. Okay, that's all we need. So I'm going to do that, and my numbers match up. So my regression, my cubic regression formula is going to be A, and these were my T values in here for list 1. So it's going to be A of T, even though the calculator is automatically just going to show you X. It won't make the change of letter. So it's just how it presents itself. So equals A, and I'm going to take that to 4 places, times X cubed. And then plus B times X squared. B is a negative number, so it's going to be minus. Taking that to 4 places gives me that. I'm not going to be able to fit this whole thing on one line. Then plus C times X, and C is a positive number. And that 6 is going to bump that up to a 1. And then plus D. Okay, so that's my cubic regression formula that I'm getting. And yes, it matches up with what I did last night. Okay, and let's see how that fits the data. So I'm going to press Y equals, and I'm going to put that formula in. Oh, yeah. And I need to write this with a T, not an X. See how easy it is to make a mistake? Now, if you make that mistake in WebWork, it would say your answer's wrong. And the reason it's wrong is we're writing this with respect to T. So on the linear ones, on the linear questions, they actually remind you of that when you're required to do that. So I did try and find questions. Okay, so no, this is a function of T, not X. So if you're looking at your calculator, it's going to give you that printout with X. And if you type in X, it's going to tell you your answer is wrong. And that'd be the reason why. Okay. And it's an easy thing to do when you're calculating, you're staring there and you're seeing X, and so you just write X in there. Okay. All right, so we need T's in there. And I'm going to come here and I'm going to put it in, but I have to put it in, well, you use this button if it's X or if it's T or theta or N. So, but it's going to show as an X. So it's, yeah, one of the drawbacks, but I'm going to put this formula in and we're going to see how well it fits the data. Okay, then I'm going to do a zoom 9. And that's my cubic. And we can see how well that is fitting the data. Okay. So I'm satisfied that that's a correct answer. And now the question is, predict the number of AIDS cases for the year 2028. Okay. So 2028, try and get it, was an original X value. Our original X values in the chart were the actual years. And if I try and calculate my answer by doing that, that's not correct because I have to change that X value into a T value. Now, your time starts in the year 1998. So T for this one is going to be 2028 minus 1998. Or how many years after 1998 is 2028? And that answer is going to be 30. So for this answer, so for the actual year 2028, my T value is 30. And now I need to have my final answer as a sentence. The predicted number of AIDS cases for the year 2028, according to that model, is going to be this. And if I take that to the nearest number, okay, it's going to be 4,292,047. Okay, and that's the actual number. So here we didn't have where this number represents thousands or what have you. These are actual numbers here. And so this is my actual number. So if the rate of infection continued as it was. Now, this has been a while ago. This has been 20 years ago that this information was collected. And I think that the medicines available, they've had much better success in treating it. And so time is one of the things that constrains us when we're looking at data like this because the science has probably changed. Now, finally, I want to get this in before we lose our time. These exponent, now it says the red line, the photocopier here only photocopies in black and white. On your canvas, you will see that this is a red line. These are vertical asymptotes. They're not part of the function. Exponential functions have two types of graphs, and it's like this. Now, you might be asking yourself, Lordy, how am I going to tell an exponential from a quadratic? Well, because it's approaching a vertical asymptote, it's going to have a much steeper vertical approach here because it's never going to get past this line, whereas quadratics keep opening wider forever. So a quadratic, if it looks like this, then you'll see the arrows on either side, but what's actually happening with the quadratic, it keeps getting wider forever. And so there's no barrier there. And so with an exponential function, it's going to look more sharp, like more vertical stretch there. Okay. And it is very subtle. Okay. Now, the time is probably going to get me, so I have the summary here. So this tells you to use exponential regression to determine the function that best models the number of these cell phones. Now, the number of cell phones is in millions, but I put these pairings in to my scatter plot. So this is going to be my list 1 and my list 2. And when I get the scatter plot, it looks like this. And it's because of the height of this. If this point had been here, then it would be more of a quadratic. But this point is quite high, and so what's actually going on is we're having something like that, which is going to be bounded by a vertical asymptote. But you were told to use exponential regression. Now, when you get exponential regression, you're going to have to scroll, scroll, scroll. And I'm recording here, so it'll keep going. You have to scroll, scroll, scroll until you find that. And then this gives you your exponential regression equation. And C is a function of cell phones. For the year 1995, our X value was 7. From X is the number of years since 1987. And so I need to put a 7 in there, okay, and not a 17. So I'll have to adjust that. So I'm going to end the video here.